Okay, I think we're recording. Start recording. We are. Brilliant. Right, let's have a look at what we did on this sound quiz. Number 3, 1 and 2, you all got right. It was put your names in, so well done there. Number 3, I'll try and read. Which is the name for the part of the ear that separates the outer ear from the middle ear? It was the eardrum. So 15 of you got that right. It goes the pinna, ear canal, and then there's the drum that separates the outer ear from the middle ear. So yeah, it's the eardrum. How many tiny bones do we have? It is 3. One of you put 2, but we have 3 per ear, so 6 of them in total. We have 2 ears. Number 5, which 2 things can the ear detect? Again, well done, most of you. 18, yes, sound and balance. Some of you were swayed by the scientific word amplitude. That's the size of a wave. The higher the amplitude, the louder the sound. Okay, so yeah, sound and balance. We have a sound bit, the cochlea, and then we have these 3 semicircular canals that deal with our balance. Number 6, which of one, there's a strange of there, which one of these does not increase the strength of an electromagnet? This is a bit of year 7 revision that I went through, and it was, yeah, increasing the temperature. That doesn't, more coils does increase it. An iron core does increase it. Have you read the question right? But most of us got that right. Right, this one's almost half and half. So the ear sends electricity to the brain so we can hear sound. Electricity is the flow of electrons. Okay, and this is where it's tricky. Nerve cells send an electrical impulse, an electrical message. Okay, so it's electrical. That just means it's the flow of charge. So the flow of charge is electrical. If that flow is negative, so if it's electrons flowing, it's electricity, but we send positive charges. There's basically a flow of like sodium, potassium ions that move through. So charged metal atoms, they're the ones that move for us, and therefore, yeah, so the ear sends electricity is false. Well done, 13 of you. 14 of you got it wrong. If it said the ear sends electrical messages to the brain, it'd be correct. So yeah, tricky. And yet you can understand, electrical and electricity, they sound pretty similar, don't they? But sums up a lot of science. Does, on a technicality, that's not correct. It's like when we say people who come to the UK need to go into quarantine for 2 weeks. It's not quarantine, because we put sick people in quarantine so they can't spread it. These are people who are coming who might not have the disease, and therefore it's not a quarantine, but everyone in the country calls it quarantine. It's a cordon sanitaire. If we're saying it properly, we're putting people away who we don't know if they are ill or not. So yeah, there's loads of stuff wrong in the world, but most of it just gets ignored. Number 8, the cochlea is part of the ear that detects balance. That's false. Well done. It detects sound. So that's the sound kind of processing bit. Well, the bit that kind of converts sound waves into electrical impulses that then go to the brain for it to be to perceive what those messages mean. And we have to learn that, don't we? Well, I have to know that this sound that I hear is that. If I hear a door slam, when I'm a baby, I didn't know, oh, that's a door that slammed there. I've learnt that, oh, that noise of a thud is associated with a door slamming, and therefore I've learnt all that. Just like language now. All these noises I'm making, your brain is interpreting them as spoken word. Number 9, in a microphone, sound waves cause a diaphragm to vibrate. It does. Well done, the 24 of us. There's a little kind of thin bit of normally kind of plastic that, as I speak, the sound waves make that move, that causes an electromagnet to move, that generates electricity, that sends a message. Then that normally goes to an amplifier, and then that goes to a speaker, and we've amplified the noise. Number 10, sound waves are made of vibrating molecules. That's true. It can be in air, liquid, or gas. But yeah, it's also with vibrating molecules. Hence, they don't work. Sound waves can't move through a vacuum. 11, sound waves travel faster through water than air. It's true, because the particles are closer together. It's easier to if you're closer together, for the force to kind of bash the next molecule. In air, it's harder for that to happen. 12, you can experience ear pain in an airplane because there is a difference in what either side it is. Pressure. You get that pressure difference on either side of your eardrum, and if there's a pressure difference, it causes the eardrum to kind of like bend, and that's perceived as painful. It's due to the altitude. It's because at altitude the air is thinner, and the plane's trying to kind of balance the pressure, but it's not quite fast enough, and our ears don't respond fast enough either, and therefore we experience a bit of pain sometimes. Some people experience no pain whatsoever and love it. Others of us are like racked in pain every time we fly, and therefore I put off flying. But it's hard to fly at the moment anyway. One little minor plus point. People aren't subjected to ear pain from flying. Anyway, 13. Sound can travel through a vacuum is false. It needs particles, and in a vacuum there's no particles. Note how we spell vacuum as well. VACUUM. It's W, but not W. W, not W. How to confuse things. Doing well. 14. A louder noise has waves that have a higher amplitude. Is true. Well done. Almost everyone got that right. Brilliant. So that's the kind of the size of the wave, and therefore it's louder. And higher frequency noises are higher pitched is true. If it vibrates faster, we see it as a higher we hear it as a higher pitch. And if you ever played a musical instrument with strings, you know that. That if I slide my finger down the fretboard of a guitar and pluck the string, that vibrates faster than this big saggy string, and therefore we get a higher pitch. And 16, I didn't give a mark for 16. It's the only thing you should put in your ear is your elbow. I call this true. It's best to put nothing in your ear. You can clean your pinner. Which side am I out? There. Yeah. So my pinner. I get a sponge. I clean around the pinner, but shoving things into your ear, these like cotton bud things, all that does is damage the cells, the fine hairs that are there, and it will also just kind of like push the wax back as well. So ears are self-cleaning. The hairs are wafting this wax towards the orifice, the little hole, and then when you have a shower or a bath or you just kind of wash, the wax will come off naturally. So it's an old saying is that the only thing you should put in your ear is your elbow, because you can't put your ear in your elbow. But if you do put things in your ear, you only put them in very, you clean around the orifice. Don't shove them right in, because you'll damage that eardrum, or you'll cause an infection, and then that can cause problems. So look after your ears. Look after them. And that's it, isn't it? Brilliant. So if you're watching this first, next job is to watch, I think, the best of the Science in Actions with Stella and Femi. So it's probably the last one as well. So the last Femi Stella combo to watch. Watch it carefully, because then you're going to do a quiz. I put this on Edmodo, so I'm trying it on Edmodo rather than doing it this way. So that for me to see how it works, and some of the questions are multiple choice, others you have to type in, and then I'll mark the ones that you are typing in. So we're coming to the end of this topic. Friday will be the last lesson with me for a bit, because I'm going back into school a lot, and Mrs. Huff, who taught you early in the term, she can't go back into school, so it makes sense she's going to take you through the last topic on ecosystems, and then I'll pop in occasionally to say hello and take the odd lesson, but just to kind of balance the workload she's going to take on you guys for a bit. So hopefully that's okay. And it's ecosystems anyway, so. And it's a shame, because we'd normally go onto the field and like measure living things and things, but we get microscopes out. But obviously we'll have to do it in a more virtual way. But we're doing well. I think again, 27 of us have done the quiz on time, so I've only got 3 people to chase. So that's still really, really good on average. Obviously, the 3 people have probably had technical issues with Wi-Fi is the main gripe. Okay, I'll stop it there. Stop recording.